Standards Practice Week 1. So, number 1. A sporting complex charges $6 to use its facilities. Well, we know since it's just completely $6, that's your constant. The expression 0.25b plus 6 models the total cost. So that means this is C equals. To hit B baseballs in batting cages. So B is your variable, so 25 or 0.25 is your slope. What is the cost per baseball? Well, per is slope. So in order to figure that out, we would need to see what's with B, so 0.25, which would make it C. It wouldn't be this because that'd be the total cost. Since it wasn't a cost per baseball and not including the constant, it would have to be 0.25. Number 2. The sum of the angle measures of a triangle is 180 degrees, so that's the total. And sum means to add. Find the measure of each angle. So I know this plus this plus this should equal 180. So x minus 2 plus 4x plus 1 plus 4x plus 1 should equal 180. So now I can combine like terms. 1x plus 4x plus 4x is 9x. Negative 2 plus 1 plus 1, well, negative 2 plus 1 is negative 1, plus another one is 0, so I could put plus 0, but that doesn't do anything, equals 180. To solve for x, I would divide by 9 on each side, so x would equal 20. Because this cancels out. But that's not what it's asking. It says find the measure of each angle. So I would need to plug in 20 here and figure out the measure of angle A. I would need to plug in 20 here plus 1 and the measure of this angle when I plug in 20, and that would be the answer for number 2. Okay, let's look at number 3. We scroll down. A student stated that the sum of two real numbers is always a rational number. So rational means it can be written as a fraction, so like a over b. So numbers like that are 3, 0.78, 1/2. Is the student correct? Explain why or why not and provide an example to support your answer. So real numbers are any numbers you can think of on the number line. So let me read this. So real numbers, any number on a number line that you've covered so far. There are numbers that are not on a number line that we've used, such as imaginary numbers, but we're not worried about those. So are any two real numbers always going to be a rational number? Well, let's try irrational. So let's say pi, which is irrational, plus 0, which is rational because you can write it as a fraction. So that's the same thing as 0 over 1, because you can always write it as a fraction, equals, well, what's pi plus 0? Well, that's pi. Is that a rational number? No. So this is not rational, so the answer would be incorrect. And here this would be a counterexample, an example to prove that it's wrong.